Hello everyone. Not sure if I'm live yet, but just gonna wait a little bit, have people funnel in. How's everyone today? So, today we have some new stream goals. First and foremost, what we designed. Hey, how's it going, Doug? What we designed last time was this. It's all 3D printed now in all of its glory. So I can walk you through the parts we've designed. So here is the internal hub with the cutout for a bolt. I have not gone to get a bolt yet. This here is the spindle, and these two fit. Actually, the tolerances are ideal at the moment. If you could feel this, that would be awesome, but you can't. So that works perfect. These holes need to be stretched, but I think what I'm going to do is I'm actually going to redesign this thing. And the reason why is because this is a fairly large wheel. This is from an 1/8 scale. Yeah, I definitely, I basically have to print when the electricity is a little bit cheaper. So yeah, this is a large wheel, and this hub barely fits inside. So we're actually going to shrink this way, and I actually have an idea to redesign it without this little holding piece here. Where's my screwdriver? Oh yeah, and I'm mobile. Was I mobile last time? I'm on the wireless lav as well. So, I mean, this worked out, but it's not what I'm looking for. I'm gonna have to modify it a little bit, and I think I'll make this a 2-piece design. And so the wheel bearings will stay captive inside without the use of this this extra piece here. So I'm just opening this up here. So, I mean, everything works. Oh, I was on the lav. Okay. Yeah, I don't remember what was going on. Starting a new job next week, very likely too. Which means I don't know what's going to happen with my channel. I just know I need to focus on making videos. So I might need to redirect these live streams to be making PCBs and stuff. So there's the little attachment piece. Not sure if you can see that. And then here are the wheel bearings. Now to get the wheel bearings out, they only go in one way. They come in this way. So to get them out, you have to press them out this way. So there's one fell out. The thing is, you also have to press them fairly straight because the fit is extremely tight, which is fine. That's kind of like how a wheel bearing is set up. There we go. So that's out now. So again, the tolerances were pretty much perfect from the get-go. There's a little spacer piece, and that sits, you know, on the outside race of that. So it allows the inside race. If you look inside here, well, I need to bring up OBS. Give me just a moment here. Problem is, I'm showing you stuff, and I can't see it. So there we go. So if you see, it only sits on the outside race. So the part that's stationary here is what supports this part. And the part that rotates on the inside here is free to rotate just about this axis here on the inside. So everything went well, but I think we need to shrink this. Way too big. So at the moment, what we have is something like this. And it's a 1-piece design. And this is why we iterate. Okay, so at the moment, it sort of looks like this, right? Big hole here, and then the bearing hole right in the middle. Sort of like that. So what I want to do is I want to move these in. These should go, you know, somewhere around there. A lot tighter to try to shrink this a little bit. And I'm going to probably shrink in like so. So it's a little bit smaller. And also I'll add screws probably around here. And that'll tie the two halves together. So we'll have something a little bit smaller, so we won't need such massive wheels. I mean, we could still run big wheels, but we won't need them in the future. So the goal will be to shrink everything down. We also need to add some steering arms on the sides, sort of like that. And again, they can't be super wide. They should be only about as far apart as this. So we're going to add some steering arms. And yeah, we're going to make this basically two pieces, you know, cut in half down the middle here. You'll put the two pieces together, which will secure the wheel bearings in place, and then it will be captive inside there. You still need the spacer. So basically you'll just put, you know, a bearing inside one of the halves, put this on top, and then the other half will go on top. The bearing will go inside that, and then this will go on top like this. That's the goal. So we're going to be working on this today, and then we're going to be working on this. So this hub, how's it going, Johnny? This hub here, this part is fine. So all this is fine. That works just fine. But now we need to figure out a way to drive torque through here. And so this is like this, and this will probably have to go sort of like this. Just think of a semicircle. Okay, like a cup like that, so that'll be all one piece. But the inside of this, if we're looking at it from the front, it'll be probably like this. And then an axle piece will be able to go inside there to actually drive the wheel. So that is the goal. And again, symmetry is a big goal, so we're going to make these things, they'll be the exact same for the front and the rear. So that people, because this is an open source platform, people will be able to make their own, you know, platforms. They can do four-wheel steering if they want. They can do dynamic toe adjustments. This will all be whatever people want to do, basically. So that's why it's very important for me to have these things be symmetrical and easy to print. So that is that. That is what we're going to do. I didn't even open Fusion yet. So hopefully it'll let me connect, because sometimes it asks me for my password and I forget it. So there's that. Don't need to be on there. So yeah, this is my process. This is the iterative part, and in fact, when I was designing the snowspeeder, this is why the snowspeeder takes so long, because you design parts, or I design parts, I should say, and then all the parts are iterations. So here's a part for the snowspeeder. So that's like a chassis. Didn't go so well. Here's another chassis. Right, this one is a failed part. What else? Here's a earlier iteration of one of the brackets for my 3D printer. Here's another early iteration of a bracket for the 3D printer. There's another bracket. Here's the first generation skis for the snowspeeder. So, I mean, it's pretty obvious that I generate a lot of this stuff. Here's a gear tried to print. And so, yeah, I mean, it's obvious that I go through a lot of plastic and stuff, but this is the only way I know how to design, is to iterate. At some point, I'll be more comfortable with designing things on the fly and kind of understanding the geometry as I go along, but that's just not the reality of the situation for now. PLA, Doug, I know you're just joking, but for those of you who are concerned, because there are some people who are concerned, and rightfully so, let me switch to screen. There we go. Rightfully so, right? It's totally fine to be concerned about it. PLA is a recycled material. So there's that, and it is biodegradable to a certain extent. Not super bigly, but to a certain extent. But what is great about my use of the PLA is this is all my waste PLA. And during the winter here, I think when heating is kind of expensive, I'm going to be using a heater, and I'm going to try to melt the PLA together and make sheets out of it, and then use a CNC machine to cut those sheets out into interesting shapes and stuff, or maybe like bottle openers or stuff like that, so that hopefully it gets, even my waste material gets recycled. So that's the plan. All right, so let's bring up the sketches here. So the problem is I'm not 100% sure. This is my geometry here. So this is what I need to change. Let's just hide the bodies. So yeah, this is one of the designs. I need to move these down quite a bit. Where's my other sketches? Here's another sketch. Yeah, that's the inside dimensions for the wheel bearing. I'm going to need that. Okay, so that should be pretty good. Yeah, I plan on it. It should be pretty neat. I mean, I like the concept personally. I think it's really important to recycle stuff as much as possible, right? The order is reduce, reuse, and recycle in that order for a reason. Okay, so let's start a new sketch here. As long as I'm on the knuckle part, there we go. Knuckle part, we're going to do a new sketch. We're going to use this plane here. There we go. And okay, so I need to reuse the diameters here. All right, so over here, don't know if that's actually latched onto that circle. I think so. So that's the outer, and then we have an inner. Where is that? Yeah, so let's see here. Maybe I just need to take the measurements off that one. This is new to me, by the way. I'm not super familiar with using Fusion in this way. There. 35.822. It's 35.822 by 2. $71.644. That doesn't sound right. But I definitely want to keep both those. What happens if I just try to make a... Will it latch to that circle? I might have to go back and get my original numbers. I feel like I'm missing... oh, here we go. This is what I was missing. Okay, let's delete this one. Okay. So I think this makes a lot of sense here. So this is... Yeah, 46 mil, that makes sense. And then that would be the bearing inside diameter. $39 mil. And then the bearing lock. Yeah, this is complicated. Let's see. It's supposed to be 32 mils on the outside of the bearing. So is that to here? Yeah, 32.2. So that's a circle I need, but this is not a circle I need. Remove. Delete. How come I can't delete this? Because it's from sketch 1? I don't want the sketch 1 one. I want the one from sketch 9. Delete. There we go. Okay. Alright, now we need a lip. So the lip will be here. And this is what holds the bearing into place. Yeah, 30.2. That makes a lot of sense. Now if I remove all this crap. Okay, that's good. Figured it out. All right, so now we need to drag this in. I need this a lot closer. So do you guys like the fact that I have a different YouTube channel for live streaming? It's going to be a bittersweet for a little bit because I don't think many people know about it still. All right, let's do a construction line. Up, let's say the center of that circle be a lot closer. 26, what does that look like? No, I need some space. 28, we'll go 30. 30 mil down there, and then 30 mil down here. There we go. That should be good. And now we need a hole. How big is that? 15.2. It's because I have a 15 millimeter sphere. All right. 15.2. Like so. I think that's going to be a lot better. 15, and then this one here, 15.2, same thing. There we go. Now I need this hole a little bit bigger. So if we inspect this, 4.4, let's make that like 6 mil, 6 or 7 mil. It needs a lot of movement. I'll go 6 mil. I think that should be okay. Like so. And then this one here, same thing. 6 mil. That should be about right. Now I don't think I need to keep these other sketches up. This is going to be our new hub. So all we're going to do now is we're going to probably do 5 mil up above here. And then close that up. So that's not bad at all. Which channel is which? Yeah, I think there was a few people who were asking for this channel to be separate on my Patreon, and I mean, I guess it does make a lot of sense. I just find it a bit sad because there's a few people that aren't here that are typically in my live streams, but I don't know how else to advertise that I have this. It's 20.2. So do 20.2 there. We can actually move this whole thing down a bit, but I think I'm going to run with this for now. And this 20.2. And I do understand how this is not the most compelling watching experience. Completely get that. All right, so this should be thick enough. Make a line going like this. And then make a line going like this. And make a line going like this. Make a line going like this. Okay, I'm gonna lock this. I'm gonna lock this. Then I'm gonna grab this guy. I'm gonna make it tangential to this. Oh, I need to lock this guy too. Take this line, make it tangential to this, and then I'm going to snip away these guys. So that should give me my basic shape here. So this tangential to this, and then this tangential to this, and then this to this, and then this to this, and then snip away the extras. 1, 2, 3, 4. There we go. It's going to make a nice smooth design. And then this to this, and then this to this. Snip them away. Wow, that didn't take long. We actually have our basic outline. The only thing I also need to do now is I need to set up the steering arms. Now the steering arms, I think they should be below center. So there will be an upper and a lower, which I didn't really want to do, but it is what it is. Because if I do it above center and then the arm goes on top of that, it's not going to go well. So I need to do like a rectangle. Started in here. I think 5 millimeters is plenty. So 5 millimeters, we're going to stick this out. How high is this? All right, let's measure. From the center to the very top here. 19.9, and so if we make construction lines from here out this way, 19.9 millimeters. That doesn't make sense. Something's wrong here. I want to inspect from here to the top. Oh, that's to the center. 19.9 plus 20.2. Oops. Oh, plus half of 20.2, so 10.1. So 30 mils. That's not bad, right? 30 mils. I think what's cool is when it's a little bit smaller, it also will take less time to print. I'm trying to make this so that everybody can do it. All right, so 30 is there. Turn that into a construction line. Do the same thing over here. 0 degrees, 30 mil there. Turn that into a construction line. And then I can grab my 2-point rectangle down 5 mils of thickness. Hopefully that's going to be tough enough. And then over here, I'm just going to stretch this out to here. That should be good. And then same deal over here. Like so, 5 mils of thickness, and then stretch that out over to here. There we go. Should be a nice piece. We need some screw holes, which is good. And then we need to cut, so we need to cut screw holes for M3 screws. That's 3.2 millimeters. So we need to do a pattern where we're going to get the corners in the exact same spot. So how do we do a pattern? We can do a center rectangle like so. I want a reasonable pattern, 22 by 41. Kind of want to out more on the fringes here, although the holes are going to be bigger than I think. Oh yeah, the bearing bore. Okay, the bearing bore is this one here. So I have to stay away from that. I want it to be wide enough. Where do I put my bolts? I think this will do here. So the other thing that the bolts will do is, because it needs structure, it'll also give us some rigidity. Let's go 40 by 20. There we go. Turn that into a construction line. So what happens is the 3D printer, in the empty spots, it basically adds rigidity. When you add holes through empty spots, it makes like a through, like a through structure, which is pretty neat. All right, and we go 3.2. Yeah, I may have to adjust this, because then my nut is going to go right up to the edge, I think. Let me measure a nut. See if we can switch to webcam view over here. All right, so I do need to put a nut sink a nut into these things. So I like to just grab the nut I'm going to use and then measure that out. So this is the kind of nut I want to use. This is M3 nut with nylock. So it has nylon on the inside of the nut here. And so, I don't know if you'll be able to see, but it has a 5.4 millimeter hex pen. Where'd my pen go? Here. Okay, so do a hex like this, and that's between here and here is 5.4 between the flats, but you do need to add 0.1 on each side, so this will be 5.5, 5.6, so we need a 5.6 millimeter hex. So that's how you figure that out. There we go. Back to the other end, screen. So this is where we're going to figure out if we made it too tight. So 5.6. Now I need the half of that. Great. 5.6 divided by 2, 2.8. Let's try that again. Polygon. This, and then 2.8 millimeter. Oh, it's gonna be frickin' tight, but I think we could make it work. So let's see if we can make, so like this, and then this side parallel to this side. There we go. Hopefully that didn't decenter it. Hopefully it just rotated it. It's not decentered. Okay. Good. And now we need to mirror this over. So we'll grab this and this. And we need to mirror that. Mirror. Objects, yeah. And then mirror line would be this guy. Oh yeah. Done. And then this guy plus this guy. Oh, I think I only need to do this one. Hold on. Let's see. Mirror on this guy. No, I needed to do both. So objects and this. All right. So that's all mirrored now. So this will be narrow. So I'm a little scared here. This to this. That's like 1 millimeter. Should be okay, but always scared of that. Okay. So that should be good for that. We should be, oh, I hope that didn't delete anything. That is, I think this is it. This should work. It's a slightly more complicated design, but it's not that complicated in the big scheme of things. All right, now the other thing I want to do is I want to take a look at this body, and I want to get exactly half of this plus 5 millimeters. So let's check. There to there. That is 32. So half of 32 is 16. So 21. So I want to extrude to 21. Okay, good. All right, so what am I extruding? So let's grab this, this, this. Oh, I'm still inspecting. All right. So I'm going 21, right? 32 by 2 plus 5. Yeah, I have to extrude 21. Okay, so I'm just going to extrude what goes full height for now. So this, 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 that, and that need to extrude up 21. Okay. So that's good. Good. Now, we need the... Oh, did I go down 21? Oh, I was upside down. Oh, that's not good. Can we... Do these still fit in there? Yes. Okay. All right, we're fine. It's symmetrical, so I'm good. Now, actually, these go up 21 as well. This and this, we need to extrude up 21. Oh, something didn't work. Missing the little corners. These guys too. This, 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 this. They also need to extrude up 21 and join. Okay, how does that look? That looks okay. Oh, what happened here? Oh, that's just my sketch, right? Yeah, solid piece. This does look weaker though. Oh, yeah, that's actually part of the plan, Doug. I'm going to... So this is like the prototyping phase, which I do basically off camera typically. And then it'll amount to a full video on the next one, on the main channel. So great minds think alike, my friend. We already came to the same conclusion. All right, so I need to chop. Oh, is that? Okay, no, damn. All right, I need to chop out some holes for these nuts to sink in, because I don't want to be holding the nuts with a tool. They should just be sitting inside their own hole. And so we're going to chop out about 5 millimeters here. So extrude. 5 millimeters, and that'll do a cut. There we go. So those nuts will fit inside of there. We do want to extrude this up by 2 millimeters. That'll be the lock ring, so that we can sink the bearing in this side. And now actually we should be able to turn on the bearing. Yeah, and it sits perfectly in there. So that's good. That works very well. Now it's these spheres, right? I do want this 5 mil up plus yeah, 5 mil up plus half of 15, so 15 by 2, 7.5 plus 5, 12.5 mil up. So we want to extrude this up 12.5. And then the plan is I'm going to cut a semi-sphere out of here. It should... Does that make sense? Did I do this right? Just thinking here. I feel like I did not do this right. Because here that means 5 mils plus a semi-sphere. So this should be exactly the semi-sphere. So I should be able to bring this up all the way. .5. Oops. I should be able to do this and then simply cut a sphere, a 15 mil sphere out of this surface, and that should leave me with my clearance. I believe that is correct. Also, I don't know about a time lapse specifically. Maybe if it's a time lapse, it'll be going in the corner of the video. So yeah, I should be able to cut a sphere on this plane now. So I'm gonna call this something different. Rename knuckle knuckle V2 1. So this will be half. Okay. So now, yeah, I should be able to cut a sphere here. And we want that to be cut 15.2. So we need to get another sketch done on the very top here. And we just need a point on the centers. In fact, I could probably just align a line like this to the center here. Okay, and then grab this and then just like so. And then here, I should be able to create a sphere on this very point. Stick it right there. And it should be 15.2. And that should cut. Yeah. And then I should have 5 mil left from here to here. 14 mil. I have messed that up. What have I done wrong? Oh, because I did it backwards. Okay, so this height here, I did do something wrong. This is 21 when it should be 5 plus half of 15, which is 12 and a half. I actually wanted it 12 and a half. Okay. See, this is why we iterate. That's okay. Everything is fine. Take this. So that's 21. Gotta go 8.5 down. Extrude this one, negative 8.5. Right, that should be the center of the sphere. Okay, let's see what happens. Okay, right, and then can take this sketch and I can delete the sketch. I can create a new sketch on the top surface here. Grab a line, make it a construction line, very center there to very center there. Finish the sketch, generate a sphere right on the middle there. 15.2, that should cut. That should be exactly perfect. And same thing, generate another sphere. That plane on this hole. 15.2, cut. There we go. So that should be good. And then I can taper this hole. Actually, I'm going to select both holes like so. Give them a good chamfer, like so, just to give my stud some movement, my bolt some movement. Should be plenty strong. Maybe 3.5. 3.5. Like so. And then my other piece on top will be exactly the same as this, except it will be, yeah, it'll be a second part. And it will have the other side of the sphere. I type 5 plus 15 divided by 2 in the box just so I can see the thought about it afterwards. Also saves me from calculating it wrong in my head. Oh, you mean in the measurement box in here? Can I just put it directly in Fusion? Because if so, I agree, that's a really good way to go. All right. So I think this is good. The other thing I'd like to do is some registration marks, like maybe a couple of lines. Neat. Thanks for the tip, JB. But yeah, this is looking good. Am I the only one who's like admiring this? Like, this is looking pretty nice. I'm liking it. Okay. And now I need to make the other half. So if I just go back to my sketch, that one, I can hide this part. And I can grab all of the relevant things that need to be pulled up. That includes inside of here. I will not pull up the steering arms though. That's not what I want to do. This, this, this. This. Oh, no, I hate that. I accidentally get a line, and then this. All right, now I want to extrude this. So now I need to go up to 32, but I have 12.5 already. So 12.5. Oh, here, actually I'll do it in here. Right, so I want to do 32 minus 12.5. Oh, hello. And then I want new body, but I want to start offset 12.5 millimeters up. Okay. Okay. Oh my god, it arrives perfectly. Look at that. Okay. Good. Hide the sketch because there's too much crap going on. This is working phenomenally. All right, now I still want to cut the spheres out of here. So let's do that. I do have a sketch for that, right? I do. So I want to generate a sphere. This plane, this hole, 15.2. Same thing, another one. Generate a sphere. This plane, right on there, 15.2. There we go. I'm glad you think it looks good, because I keep blowing myself away that I actually have the ability to do this. Mind you, it was hard won. Like I wasn't born knowing how to do this, but it's quite cool realizing that you have, it's like unlocking something. Okay. So now the only problem is I didn't want it to be this fat, but I do want it this big up here, and I can only taper this back at a certain angle because these things have to stay flat for the screws to sit. And also I have to contain that sphere. So I will deal with that now. I'm going to try, see what happens if I take these two guys. I'm going to do this, really. And what happens if I chamfer it? No, it chamfers the whole part. I don't want to chamfer the whole part. Just want to chamfer like this end. So I'll have to cut. I think I'll have to draw something here and cut it basically like this. Take it, yeah. So what happens is, because I need the lock ring here, which I'll just extrude now because I need to do that. Because I need this little thing here. I'm gonna extrude that up 2 millimeters, but offset 30 mils. There we go, so it sits right there and it's gonna join, that's fine. All right, so this needs to sit flat on the 3D printer. So I can taper this away. The 3D printer can like print suspended in the air, but I just have to go kind of aggressive on the angle. So I have to figure out some way to cut it. There, hide these two. I can rename this too. So, knuckle V2, 2. There we go. I have a lot of material I can cut away. So if I do like a 45 angle from here, but the only thing is these have to be flush. If I would have like brought them in more, that would have been a little bit better. But I did want it out quite a bit so it would support the sphere here, because that's the racking that's going to happen. You know what? I can try just printing it like this and calling it a day, because this is prototyping. I think I might do that. Okay, so next thing I want to do is registration marks. So basically, one of these two parts needs a protruding feature here, and the other side, this side I presume, needs a like a concave feature. So it has to be something that the 3D printer can easily print. And I basically am going to use that to add strength. Because just these usually screws are not precise enough. You do want something with like some meat to hold it together. So yeah, I'm gonna design two features, like one here and one here with some thickness. Yeah, exactly. tongue and groove. That's 100% the principle. And if you make it kind of big enough, it should hold really well. So I'm thinking just like some triangle surface thing. So if I make like a rectangle, I don't know, or I can make some pips that can be like semicircles, although triangles are probably a bit better. Let's see if I can create something. Torus, a sphere. Yeah, cylinders are easy to create. So is a box though. Maybe I'll just make a box. Have to be able to find the center of these things too. Grab the middle. Grab the middle, and I don't know what the middle, what this is the middle of. Yeah, that's not what I wanted. Okay, I'll just make a sketch. I didn't really want to make a sketch, but I'll make a sketch. Okay. So I will make a rectangle. See if we can go in the very center here. Can I grab the center of this? Nope. I don't think it matters. Let's go here. Kind of want this feature to be kind of big, but also even. So let's say 12 mil by 3 mil. Sure, there we go. And let's grab the very middle here, like so. And like so. Can delete this one, doesn't matter. This one turn into a construction line. Grab this guy, mirror it on this axis. Oops. Mirror it on this axis. Okay. And then what I can do now, finish the sketch, grab these two fellas and extrude them. This one is taller. I'm gonna go down 3 mils. Yeah, and I'll put all the tolerances on the other piece. So down 3 mils like so. This will have the bonus effect of strengthening kind of all around here. And then the other piece, hide this, grab this guy, grab that sketch back. Okay, grab this guy, and take it up 2.8 mil, because you do need some clearance. 2.8 mil, like so. Hide that sketch. And then grab these, all these walls, and we're going to shrink them by 0.1. There we go. Oops, I should actually bring that up by 0.1. There we go. If you put a bump and groove on each half, it'll prevent backward assembly. They're symmetrical, so I kind of want my viewers, people, whoever's going to make these, to be able to sort of do whatever they want with it. So I'm not worried about doing it backwards. But if I do add some features, then I will, like some features that make it where it has to be one way or another, then I will definitely do that. Oh, so that one worked. Why doesn't this one want to chamfer? Chamfer 0.5. Okay, and then if we maybe we should chamfer everything. This and this and this and this. Chamfer that. Chamfer 0.5, sort of like that. And then we can hide this piece, grab this piece, and do the same thing, internal chamfers on here. And since we already built the clearance in, it should be okay, but it's going to be nothing that a little sandpaper can't figure out anyways. So we're going to chamfer 0.5, and same thing here. 2, 3, 4, 2, 3, 4, and then chamfer 0.5. There we go. So these two pieces should fit together like cake. All right, so now all I need to do, so the thing is you can only really cut in at 45s with 3D printer or more aggressive. So I'm not sure if I really want to do that here. I do wish this was more compact because it's only really this section here that needs to support the bearing, that needs to be that strong and tall. But if I cut away this section and make it narrower, because I can easily do that, the problem is that then you have to print with supports here, and printing with supports is stupid. I don't like it. I don't want to print with supports. I think it's actually faster to leave this chunky. It just sucks I can't just like chamfer this side. I have to chamfer everything. I want to chamfer... I kind of want to chamfer it like this, to be honest, but only around this section, not around here. Even it can chamfer more. You can go like this far, right? So that's all I would need here, but this is going to get chewed up. I can't do that. Kind of disappointed with that. I kind of want to chop this and just chamfer this corner. I can chop it. Let's see. I'm gonna try to chop a little bit. And if it doesn't work, it just doesn't work. It's not that big of a deal. So if we take a line, and we go sort of like this, okay? And then this, that's from another sketch, that's okay. So if this is tangential to this, and this tangential to this, so then I can literally chop this down and then bring it back at a 45. And then I will grab a line. Okay, from here to here, turn this to construction line, grab this, mirror it with this as the line. That's done. Finish the sketch. All right. So I can take this and I can drop it. Let's say 10 mils. I can do the same thing. Take this, And I can drop it, let's say 10 mils. Oh, 9, 10. Okay. Then you can grab these sides, get rid of this, like this, like this, like this, like this, and then you can chamfer them out. Non-manifold edge or vertex. I did a mistake. Okay, so let's modify this again. Bring this, we'll delete this, and we'll move this. Move it. Actually, I just needed it 1/4 mil, like so. Do you need more material at the screw hole? Yes and no. It's not super necessary. Plus, you can add it back after. All right, let's try this again. So, I'm gonna grab this and drop that by 10, like so. Then I can grab this and chamfer it outwards. Oh no, yeah. So I get this, which is fine, but then look, there's this, and you can't 3D print that. Although, hold on, let's see if we can now grab these guys and chamfer. Chamfer. I mean, it's close, but I think you're encroaching on the sphere now. Yeah. Let's go 7.9. Nope. 7.8. It's 7, 7.6, 7.5, 7.4, 3, 7.2, 7.1. Yeah. So, yeah, that isn't really working. Because you can definitely 3D print a you can 3D print a 45. That's easy. It's this here that'll need support, and I don't want it I don't want support. But that's a big chunk of plastic too, which I'm not happy with. Because I can make that a gradual angle down, but again, it won't print well. So I can leave it like this, and I can print it, and we can just see what happens. I don't think it's the end of the world. By the way, is my audio still good? I haven't really been checking. Looks like it's in the green on OBS, but I'm sure my voice isn't like super consistent. Okay, so I'm gonna accept this. This is the 2 knuckle halves kind of done. Oh yeah, I gotta deal with the steering. So this guy. So these features should lock these 2 in place. I'm not worried about anything else. Then I can chamfer this. Probably to like there. Probably going to chamfer it less, in fact. Let's go 7. I'd say audio's good. Lower end of normal, no need to adjust. Okay. I do have the mixer right next to me. I can adjust it if needed. Thanks for the input, folks. Thanks for being in the stream, actually. There's only 3 of you in here, I think, at the moment. I can't tell. Maybe just 1, couple. It depends what YouTube decides constitutes a view. 3 mil. Like so. All right. And now we got to drill a hole through here. I'm thinking of using an M3 screw. I don't know how I'm going to attach it yet, so I'm thinking M3 screw for now, and then we'll figure it out. I think this looks really cool though. I'm just going to fill this with grease so that the ball joint slides around pretty well. These are going to be a little bit hard to print. These need supports, but that's okay. I was expecting that. So that's good. I get to a point when I'm designing this stuff where I'm excited to print it. So that's pretty neat. I'm glad I put registration marks in. I might put some more registrations in the future, but I think this is good for now. Should be locked in pretty well. All right, so we need to drill holes. Stop messing about. So one more sketch. I'm gonna put it on this plane. We need a 3, well, we need to find a kind of like a good location. What's this the middle of? No. That's awfully thin. That is very thin over here. Let's see if we can delete the concentricity. And we're going to move this in. Might not be a lot of steering authority on this thing. That's okay. All right, now we need to mirror it over this way. So get our mirror line. Got to be a center point here. I really should have just built everything on the I should have built everything on the actual center here. Oh well. Here goes this. Turn this into a measurement line. And then from here to there, that's 5 mils in. Yeah, that's exactly 5 mils in. So I can just grab this from here. Like this, turn this to measurement line. Grab that center point here. 5 mils in. No, not that. No, not that. There we go. Turn that into a measurement line. Then make a 3.2 millimeter circle. And that should be identical. And finish sketch. This guy and this guy. Need to extrude. Pop it right through those holes. There we go. I think this is finished. Surprisingly. Wonder if I taper this down to the middle here, I'll have enough meat to grab this, but no, you know what? I want to distribute the forces, so I probably won't do that. Okay. So that looks good. Let's give our knuckle parts some colors. What was our other knuckles color? Sort of greenish. So we're gonna grab appearance. Sort of like this greenish. I think it was this. Bing. And then this. Make it the same green. Bing. So these are two parts, but they are still part of the same thing. And then our whole assembly should still fit. Oh yeah, we don't even need this lock ring anymore. Oh, and I have my, this thing is through it backwards. Oh well, that's okay. Neat. I'm gonna have to rearrange this because it's gonna bother me. If I go too far, it's gonna bother me. So yeah, there's our assembly. And you can open this up. So there's the bearing, there's the spacer. So you still need to slide the spacer in, which is okay. The registration marks should add up. Pretty cool. So I designed the back half on the front half. Oh well. No big. Cool. I'm actually pretty happy with that. Now, do I design the axle hubs? I didn't reduce the like the depth, but I did reduce the height. And the old one, there's the old one compared to the new one. So old one, new one. A little bit of a difference. So I'm actually not sure what that adds up to, but I really like the sleekness of this. I think there's going to be a lot less material to print with, which is nice. I also have a sponsor that won't mind making these for me. So if I need to make them in tougher material, I've got someone to print it, which is neat. Oh, I'm going to chamfer. You know what? I can add strength by chamfering these edges. So I think I'm going to do that. Grab this guy. Am I still in the knuckle? Yeah. Should be able to. Are all the sketches gone? Yeah, sketches are gone. Don't want to grab this. Oh, I'm still in the appearance, that's why. Close. Go away. I'm going to grab this. 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 And this, and I'm going to give it a fillet just to smooth it out a little bit, and I'll get a little bit more strength out of the part like that too. Good. Looks a little bit cheesy now because it doesn't match up to here, but that's okay. It looks a little bit more organic too, which is neat. Should I sink these bolts into here? No, I don't think so. I don't think so. All right, let's deal with our axle hub before it becomes too much trouble to deal with. I don't think I've dropped any frames. That's pretty neat. All right. So that, don't need the lock ring anymore. Can actually rename. Just call it deprecated. Okay, so take this axle hub, take the body, and I need to rotate it. So let's go on here. I can just quiet down all these parts here. Oh, I can't do that. They're all part of that. There we go. This. All right, I need to 180 this. Move copy. Okay, and now I need to check where the bearings line up. I just need to move it a little bit down. Move copy. Oh, here. It's like 1.5. No, less than that. 1.2. Yeah, there we go. And now that should give us, everything should look all good again. There we go. Now we're set. Neat. You must be a fan of Elon from a design philosophy standpoint. He's built more than 27 Starship prototype and 8 boosters prototypes so far. So, I think what is positive about Elon, there's a couple things I like. A is that he made electric cars be cool, because to me they were always cool, but a lot of people didn't understand how cool they could be. So that's A. And B, I do really like his like the philosophy of sort of trying to make spaceflight more economical and stuff. I do like that. So don't get me wrong, that's a good thing too. But the problem is that he's a bit of a dipshit otherwise. And I think that's a little bit of an understatement at times as well. So, yeah, it's a shame. I do like some of the things he's done, but not everything. Because, yeah, he's a bit of a dipshit. He also totally could have fed a whole bunch of people, but instead he had to feud with people on Twitter. So he bought Twitter. You know, kind of wish I could just do this. Add a little bit of a chamfer there, just to make it a little bit more clearance happy. I can save material actually by chamfering these two. Might do that. It'll also add a little bit of rigidity. Can have it meet up with that. Might be a little hard to print though. I'm gonna give it more surface. There we go. 3D printer should be able to easily print that. That's good. That looks nice. Might chamfer. No, I can't really chamfer these edges too much because this comes really close. Yeah, you know, I wish he wasn't involved in Tesla, to be honest. He didn't even found Tesla. Do you know that? He actually bought the company. He bought controlling shares. So he's an early adopter of Tesla, but he definitely did not found Tesla. I think he sued some people for the right to say that he founded Tesla. Yeah, and you see that's the problem, you know, is that we remain complacent because we don't actually think of it. Okay, we need another component. I'm going to do the ball joint on the inside here because those might be easy to print. I do need to take a couple measurements first. But then, basically, then it's working on the difficult part, which is this axle hub, or we can do the control arms. I don't mind doing either. Can I do a pole on here? Pole. No. Participants? No. How do I don't know if you need to be like a super cool streamer in order to make a poll. Live chat, okay. Yeah, I guess you're the only one here. Oh, engage with your audience. Start a poll. Yes, okay. Which part is next? Ball joint? No, but ball joint I'm gonna do next, but after the ball joint. Okay, let me see. After ball joints. Okay. control arms. Or axle drive mechanism. What else could we do? Oh, we could do the wheel. Wheel tire. And then what else? I think that's it. All right. All right. Pole is up. There we go. So just in case there's anybody other than Doug and Vero, are you printing the wheels or using the one we've seen? Hold on, I forgot. Printing. Actually, 17 mil is a standard. I think I may have some 17 mil wheels, but I think I'd rather print them, to be honest. Because again, I think the plan for this is to have as many 3D printed parts as possible, because then it'll open it up to more people being able to use it. Oh no, my coffee's gone cold. My coffee's gone cold and I don't know why I got out of bed at all. Oh, control arms, huh? Looks like control arms are number 1. I'll start doing the control arm work, the ball joint work, and we'll let the pole go for a little bit. But it looks like, oh, axle drive mechanism. Okay, so webcam. All right, for the ball joint. So for the ball joint, we already know that we have the hole here, the sphere. So we need something like a 15 millimeter sphere. Okay, from side to side. But then the plan is to sink a bolt, and I think I size it for an M4, so 4 millimeter bolt. So this guy, I may have to order some different ones, because I don't think this is long enough for my design. But basically, the deal is, I need to bring this up. A little bit, okay. Anyways, the deal is that this bolt will sit inside here. And so there needs to be enough meat left sort of underneath here in order to support the bolt. And then we need to carve out the head and we need to cut it all the way out kind of to there. So the ball joint will be sort of like that. So for that we need to take measurements. Now this is the only M4 bolt I have at the moment, but it does have to be a hex cap screw like this. So that'll sit just nicely inside of the ball joint. And what's nice is that the 3D printer will be able to take the flat created by this hole in the middle to start the sphere and then go around. You can even do this with supports. So the 3D printer can use supports like this to build the sphere. Because it's not so bad, you just have to sand it a little bit, and then hopefully the thick grease that we're going to use to put that into there will take off the slop. May have to play a little bit with printing these. May actually have to slice it in half like this and then print this half and then glue them together. We'll see. This is what I'm going with for now because I don't really know how else to do a decent ball joint, but that could be a design consideration where we may need to stretch these out bigger. You know, this is a 15 mil sphere, and so if I'm looking at it in person, I try to make it big enough so that it'd be easy enough to print. So there's a 15 mil sphere, so it's going to be this wide, right? So it should be okay. 3D printer should be able to deal with that, but if not, I mean, we'll make adjustments, and if we have to add more clearance into here, we'll do that too. The other thing is, once this is all together, it should be such that it should be enough that it's going to work its way in, and it should loosen up over time. I'm not too worried about that because we can use thicker and thicker greases or just pack more and more grease in there to make sure it fits. But yeah, that's the goal. Again, trying to keep this relatively inexpensive for people to try themselves. So I want to be using, you know, pretty standard components. Another consideration is we might have to use that same style of ball joint here on the steering arms, right? So that would be like that, and then the cap would come over and bolt on top. But we'll have to see how it works out first. So we need to take these measurements. These are critical. So let's see. So we've got 8.53 is the head. So just going to sketch out a little bit of a bolt here. All right, so 8.53, like so. And this, you know, you can glue this in, but I think just a press fit will be just fine. The height of this head, this specific one, again, may have to buy new ones, 5.13. 13, sort of like this. The shank, 4.8, so we already know that's going to be 5. Oh wait, that's on M4. This would be an M5. That's an M5 screw. What was I thinking? Do I have longer M4s? I do like the thickness of the M5 though. Do I have M4 screws? I only have really short M4 screws. Oh, I have these guys. Yeah, again, really short. Okay, that's fine. I'm probably going to order some M5. Order M5 screws. Order M4 screws. Okay, good. Do I have M6? No, I don't have any M6. Great. Order M6 screws. That's going to be another, this is going to cost me about 30 bucks. But again, the screws shouldn't wear out. It should only be the 3D printed parts that wear out, which means you can just 3D print some. So, yeah. How's it going, Big Z? Screen. Okay. What do we have? Oh God, 2 people who don't care. And control arms and axle drive mechanism. Oh yeah, it did drop frames. 1.4% drop frames. Spinny circles at times. Yeah. Well, what do you want? Nothing much I can do. Okay, so I have my measurements. I can actually show you how much it would cost to get some of these things too. So if I want some, I'm gonna see if it maybe takes my location. Don't allow. Canada, English, Canadian dollar, save. I said Canada. Save. Fine. It's gonna stay American. M5 screw. Just want to make sure that they don't give you my location. No, don't think so. Okay. So these are about what we're looking at here, M5 screws. We probably want like 20 mil length, M5 by 20. M5. So let's see. So if I want to buy 30, it'll be That seems really cheap. I have a feeling that Canadian shipping will be more expensive than that. Let me see. I'm going to change this to Canada. Ships to. Well, I'll just default to United States. So yeah, if M5 by 20 is going to be $2, I might grab some. So that's not too bad. So I'm probably going to spend like $6 on that. Yeah, not too bad. Okay, back to work here. Stop distracting me, folks. Okay, so we need a new component. New component. Type standard. Ball joint. Okay, ball joint here. And then we're going to grab one of the sketches. I think, not this one. Should be just a line. Yeah, whatever. To this one here. Gonna hide all this crap too. Yeah, that should do. You know what? I have so much mailbag stuff to get through. All right, ball joint. We need to create a sketch on the top of this. Capture or revert component positions. Capture position. Sure. All right. So let's see. Do I have more drop frames? No, doesn't seem like it. So someone remember 4,415 frames dropped. All right. Need a line. Very center there to very center there. 60 mils center to center. Okay, and then that's good there. And I think I can just generate a part from here. I don't think I need to. So if I hide this knuckle, I can just create, and that would be a sphere on this plane. Yep. And then that one would be 15 even. Did that make a... Yes, it made a body. Great, I'm just going to duplicate it on the other side. Yeah, well I did drop, you know, several hundred frames, but that's okay. Okay, so that is right in the middle of my sphere. So I'm going to drill out a hole now. I'm going to grab this sketch again. All right, so the head of the bolt, if you remember correctly, was 8.53 in diameter. So I'm going to do an 8 point... okay, hold on. I'm going to do a circle. 8.53. And then using Johnny Bergdahl's trick, plus 0.2 for clearance, like so. And now I should be able to take that. Let's hide this body. Take that, bring the body back, extrude upwards, and cut. So that cut a hole in the very middle of that sphere. Now I do want it to go further down, so I'm going to extrude it some more. Let's say 3 mil more. good. And now we want to grab that sketch again. Yeah, this guy here, whoops, this guy here. And now the shaft was 4.8. And we're going to do a 5 mil, or we're going to even do 4.8 plus 0.2, like so. Finish that sketch, grab this guy, and extrude it to cut right through, like so. And then that should be our ball joint. All right, that's pretty easy. Now we can grab this exact same sketch. Okay, and make a circle, which is 4.8. Gonna make another circle, which is whatever this was, 8.53. 3, like so. Finish this sketch. All right, grab, no, yeah, grab this guy, and I need it 5.13 high. So extrude 5.13 upwards. That's good, but I do want it offset. I think it was 2 millimeters. Oh, negative 2 millimeters. No, it was more. 2.5. Just trying to get it to sit at the bottom of that hole. Was it negative 3? I think it was negative 3. New body. Okay. And then grab this and this. Extrude up. That is our bolt. And do the same thing. Oh my God, get lost in space here. So this and this. And extrude down. Join. Am I going the wrong way? I am going the wrong way. Like this. Oh no, 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 no. I almost made a mistake. Just the inside. Extrude. There we go. That's the bolt. Okay, so that is our finished ball joint. Hide the sketch. There it is. We just need to duplicate this entire body. 60 mils. So we take these two bodies. That is the ball. Rename ball 1. Take this one. Rename bolt 1. So ball and bolt. So there's the bolt. And there's the ball. And now we need to move them, bolt and ball. Move copy, create copy. We're going to move them 60 millimeters this way. Okay, so that doesn't look like much, right? However, now if we bring these guys back in, it sits exactly where it needs to sit. It's inside there. And we just need to bring back all our other parts. This one, the inner spacer, and the axle hub. So there we go. 2 ball joints. Done. That was actually pretty easy. I don't even know how long this needs to be, but I can calculate it now once I make my control arms. Let's go this way. Yeah, Reboot is a fantastic game, show, not game. I don't know, did they make a Reboot game? It's a good question. All right, so that's done. Now what are we making? Either control arms or axle drive mechanism. I think I'm gonna go control arms just because the axle drive mechanism is a little bit more complicated. Although I probably should print an axle drive mechanism. Whatever. You know what? I'm gonna actually do one more thing. Knuckle V1. I'm just gonna chamfer these 2 edges or fillet them. There we go. Looks a little bit better. Okay. Control arms it is. Okay, let's switch to the other screen and let's see about control arms. All right, control arms. So we already have our axle hub sort of like this, down like this, down like this, and we've got our 2 ball joints with the stems coming out like this. Okay, at some point we're going to have our axle drive cup sort of like this, and there's where the hex is, and the wheel is going to go over here. So now the plan is to make a dual wishbone setup. So what we do is we make a section like this that accepts a nut for this that we can screw into, and then this part will go over and have a sort of jointed section on the vehicle. Same thing like this, nut section here, and then this will go over and have a jointed section like this. Now one of these 2 has to support our suspension, and typically the easy way to do it is to have this end here support our suspension. So we're going to have our suspension kind of like this. There's a cup, there's a spring, and the spring typically goes in between, like off to the side or wherever, and then it is supported by a cup here and then another support onto the chassis. So you can do this a couple ways. You can have this control arm. Now if you look from the top, right, it can be like this. So the ball joint comes in this way, and then the control arm can go kind of like this, and it can go kind of like this, and then you have that shaft here going through. Okay, or you can make it go fully around, kind of like this. So either way, you need a hole somewhere for this to go through. Now the bottom one, it's a little bit less complicated. All it really needs, right, you have your nut there, all it really needs is, you know, sort of like this, and this can be solid, sort of like that, and then all you need is a place, like a hole, to mount. There's a bolt to to mount the shock on the bottom. So it could be something like this. I kind of like the idea of an A arm, like an A style arm. So basically, you know, kind of like this, and then the shock goes through the middle, but the problem with the middle is that the axle has to be in the middle too. So I think I'm going to offset the arms, the springs kind of to one side, and that means that they won't be symmetrical though. Or you can make the bottom arms have 2 spots for shocks, and then it will be symmetrical. We'll see. The other thing is this here. I want it to be big enough that you can print a pin. You can either print a pin or you can use a bolt. Now using bolts is probably the better idea, but then the issue is it's not quick. It's not quick disconnect, and also it'll start eating the inside here with the threads. Because if you could just imagine like a bolt, if you have a bolt thread like this. So if you look, this is rather rough, and so if you have an arm swinging on this, it'll chew its way through. Also, the more often you use bolts instead of plastic is the heavier it'll get. Already we have a really heavy weight going through the middle here for structural stability, and we got 2 bolts here as well. We're going to need a bolt through here because it's just too small to accept a non-bolt. So yeah, I'm not 100% sure how this is going to work, but I guess that's the point, right? We're gonna give it a shot. So we'll see what I can do. Lengthwise, you also want the lower arm to be longer than the upper arm, and that's for suspension geometry reasons. It's called a short long arm suspension. It's just the way the suspension will flex. It'll allow the wheel to stay more flat on the road for longer of its travel. So we probably need to make this arm a little bit shorter too. There is a mathematical way to figure this out, but I'm not a mathy kind of guy, so it's going to be kind of difficult. Also, this arm needs to be stronger than this arm, because all this arm does is it follows the knuckle. It allows it to go up and down. Whereas this one will take the weight of the vehicle, because the weight will transfer through the wheel here, up through the axle here, down through this, up this, and then up into the frame. So this section here will have to be very strong, whereas this section here will be less strong. Hopefully you guys got that. I mean, I could go all teachery, but I think it'll be kind of boring. So here goes. All right, so we need a section where this will slide into, and that section could be the same on both. We also have to be careful to make our arms flat so we can 3D print them easier. And as much as possible, I'd love them to be symmetrical. So yeah, I'm thinking an A arm at the top. Okay, we'll see. Let me just develop this first. So, oh, actually, I'm going to grab the nut so we know what size. Let's see, switch scenes. We also need the size, because we are using M5 for the ball joint, so we need to know the size of the nut, which is this guy here. Again, going with a nylock, so there's nylon in there, so the bolt won't release. And so we need to get the size of this. We'll go 7.8. So from here to here, that's 7.8 millimeter. good. Put this back before I have to clean up more and more stuff. Time is it now? 2:50. Might have just enough time to make the control arms. At least a first prototype, so then I can get to work on printing them. So there's M3s and M5. I also have these guys. These are heat set inserts. So this is one possibility. We can actually sink one of these into the control arm. And what it is you see those teeth? Those teeth will grab into the plastic. And so you push this into the plastic, and then you can use a regular M5 screw and screw into the plastic. The only thing I don't like is it doesn't have a way to lock into position. So you actually have to drive it in tight, which won't work because of our ball joint. But for the chassis, that's a good idea. I also have these guys, these are actually for woodworking. So they're M5 nut, but they have these spikes. So what you do is you run it into wood, you press it in hard into wood, and then you run your screw from the other side of the wood. And this is very good for that. But what you can do is you can model slots on 3D printed parts and just push this through, and then this is incredibly strong connection because it spreads the weight. Plus it's very cheap. And again, the point is it has to be inexpensive. I mean, top quality RC, a remote control car of this caliber, at least that I plan on having it good high caliber, will cost somewhere around like 700 to 1,000 Canadian dollars, and I'm trying to get everything in and done, you know, for maximum couple $100. So here goes. At least the hardware and stuff. Basically, I want people to be able to buy a 3D printer and all the filament they need for this and all the parts they need for this and still come up cheaper than buying a full-size remote control car. That's the goal. I don't know if that'll actually be a reality, but you know, I can try. So 7.8 millimeters is what we said for that. Well, I think the thought process behind it will be high caliber, but the thing is, it'll have to be iterative. I'll have to see what went wrong and how to make it better. It's not going to be high caliber right off the bat, which is completely fine. Like I'm totally, I totally accept that. New component. Let's start with the upper control arm. Upper control arm. All right, so I need a new sketch. I'm gonna hide all the stuff we don't need. Hide, we do need the ball joint. All right, so we're gonna make a new sketch on this plane here. There we go. And we're gonna start with a circle matching here. So this will be 4.8. No, actually we need a little bit of clearance. So 5 mil across like so. Oh, I wanted to offset. How do I do that? I want this new sketch here to be offset. Offset plane. Yeah. Distance. So I need to give it some clearance. So let's go like 3 millimeters. Okay, good. That's what I want. All right, so create sketch. Hopefully that is 3 millimeters up. All right, centered. Excuse me, can you just give me the center? this was a mistake. Should always just stick to what you know. Delete this. Delete this. Yeah, construction plane, don't need that. Go away. Delete. There we go. All right, screw it. We'll do retroactive precision. All right, 5 millimeters, we need clearance. That's good. And now we need the circumscribed polygon, which is, what do we say again? 7.8, so we need 7.8 plus 0.2. So create a polygon. Um, 7.8, oh, it's half, okay. Oh, okay. 7.8 plus 0.2 divided by 2. Does that work? It certainly seems like it does. Okay. And now that is like the maximum size. Now we just need a kind of like a square. Center point, rectangle. That's going to be a big control arm. 12 mil tall. I do need enough meat though. Yeah, we're going to do that. Okay. Finish sketch. Let's see what we come up with here. Okay. So we want to grab, now we can hide this. Go away. We want to grab this, this, and this, and this, and we want to extrude it. Let's say 10 mils. Sure. 10 mils. And then we want to take our sketch. Oh, wait, nope. That's not what we wanted to do. Grab this, 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 and this. We want to extrude it 10 mils, but we want to offset it. Offset by 3. There we go. So now it's away a little bit from the knuckle. So if I bring the knuckle back, yeah, good. Right, let's check out this. Now we want to extrude this, probably like 5 mil, but we do want to offset it. Offset by 10. No, less than that. 7. Is that going to pierce all the way through? No. I do want to give this quite a bit of meat. I'm going to bring it offset by 8. There we go. That should be plenty. And that is the start of our control arm. All right. That is good. I will be able to shape this after, but for now. So this is going to be a tall control arm because it's 12 mils up. How big is that? You know what? For strength, it's probably okay. All right, and now we need to make a new sketch. Uh-oh. dropping frames. Stupid. Still dropping frames like crazy. In the red. Oh boy. No spinning circles. That's interesting. The audio didn't drop, so yeah, OBS is telling me, well, it just climbed up to 2.9%, so I was at 4,400 drop frames, now I'm at almost 13,000. Oh well. All right, let's take a look at this. Now we need to check our dimensions. I think I may want to sketch this from the top or the bottom. So I think I'm gonna, from the top. Well, I got a notification on YouTube saying that there wasn't enough information for a good stream and that my viewers were getting dropped frames. Okay, so we need a new sketch. I'll start on top of this and we'll be able to extrude downwards. All right, so I need to, so this is where I do iterative stuff. I need to kind of print it first and get an idea what it looks like. If I'm looking here, I'll bring you along with me. So if I am looking at this, right, and then I need to like make a control arm for this, or even like if you think of a like this fitting inside of a wheel like this, okay, so this will sit about there. So the control arm I want, I can kind of use this to get an idea, and it probably wants something about 60 mils on the top, and then for the bottom needs a bit longer, maybe 80 mils. So let's go with about 60 mils of length on the top and 80 on the bottom. This is kind of like how I figure out my stuff. So I'll go 60 mils and 80 mils. There is like I said, a math formula to deal with this, but math, you know? Let's flip this around. So 60 mils and 80 mils. So if I grab this line, go right in the middle here, and go 60 mils. Like so. Turn this into a construction line just so I have an idea. So we're looking at a control arm like this, and that should be like to the pivot. Oh yeah, it was yellow and red on OBS. And so if I make an imaginary pivot, so basically the halfway mark has to get to here. How wide do I want it? Wait for me to go, well, I'm gonna be at least another hour. So if you want to do a regular walk now, and then we'll do a regular walk when I'm done, or a slightly longer walk if you want, when I'm done. Okay, how wide do I want this? So now when you're determining the width of the arm, the wider that the arm is going to determine the amount of stability sort of this way, right? When you're hitting bumps, everything wants to rack sort of this way and this way. So I want to go pretty wide on this. Probably probably 10 centimeters. And that should give me enough space to bring the shock through and still have room for the arm. I'll go 12. I'll go even wider. I'll go 12 mils, 12 centimeters. Oh, okay. So we want to go 12 centimeters. So I'm going to go 60 mil up. And then we're going to go 120, like that. And then this turn into a construction line. And see if I can just grab that one. We can delete that one. Okay, so this is the size of our arm here. So that is pretty big. So we can actually take a line directly from here. We can take it from back here too, but we'll take it from here. And if that's kind of the center, I kind of want it to be at least, yeah, this will give us a 45. Okay. I'm going to go, all right, I want to do one more thing here. I want to figure out about 10 mils each direction. 10 mils that way, and 20 mils that way. Can delete this and then turn this into a construction line. Like this, 20 mils. Turn that into a construction line. All right. So let's see, if I do make an arm like this, I mean, this will be as basic as it gets, sort of like that. And then we can tie into here. You can even tie in a little bit tighter. Got to have a lot of meat on the bones. Yeah. Sort of parallel with that. I'll just pass it over here and we can just make the geometry after. And then this, sort of like there. Pass it over that and make the geometry after. I want it to be parallel with that. It's going to be a hell of a wide control arm, but we'll be able to fit our shock through here pretty easily. That's good. We can make reinforcing segments. Sort of like a 5 mil. Sort of like this. There we go. Oh, shit. Thank you. There we go. Professional streamer, ladies and gentlemen. I also need to bring my chat over to the other side, but oh, well, whatever. Okay, and then, so if I can make a rectangle here. This is all just rough, by the way. I'm just trying to get this to be roughly working. 20 by 8. sort of like that. And then I can trim all this weird stuff. Hey, what's going on? Is that not... It's not planar. Oh no. Needs to be planar. Yeah, I grabbed it from other places. That's not good. Can delete this point and delete this point. Alright, should be able to grab this and stick it parallel to that. And then grab, is that still planar? That's planar. Here, and then hit parallel. Come on. Oh, there. Parallel to that. There we go. That's a very basic shape. I think we're going to go with this for now. I think we're just going to... Oh, like this, like this. Like this, this, and this. And then drop that down. Extrude. 12 mil. Fill in these voids. Fill in this and this. Press pull. Should be able to just... Yeah, sort of like that. And then just fillet all the corners, and that should be at least getting us on our way. It's gonna be beefy control arms, but I think that's the point. We do need something strong. Okay. I'm gonna fillet all the corners. Basically, when you have sharp corners, you have what they're called stress risers, which means it's places for the forces to act upon the material. When you have smooth corners, you don't get stress risers, or you get fewer of them, so that the forces are distributed more. We're going to do a fillet. 2.5. That's good. We could do a little bit more. 3.5. I think that should be acceptable. Yeah, exactly. That's why airplane windows are rounded. That's why there's a lot of engineering concepts that rely on that kind of stuff. Okay, we need to punch holes in the middle of these two. And I think that'll be enough for this control arm. Then we'll just design our next one very, very similarly, but we'll just have a spot to mount the shock. Might not even make the spot to mount the shock. I have to stop I need to start sort of thinking that everything needs to be done right away. I do like to print things out before I go on with the design. So I think 12 mils is acceptable in width. That's going to be a lot of lateral stability, but it's probably a good thing. Okay, and then, yeah, the bottom control arm could be solid for all we know, except for this hole in the top. Okay, so we can actually duplicate this downwards and create a new component out of it just to save time. So grab this body, rename this upper control arm. Okay, and we can move copy, and we will move object, body, one selected, create copy, and we know we can move this 60 mil like this, and then take that and create component from body. What did that do? What the heck did that do? Knuckle? Oh no, I'm dropping frames again. What's going on here? Upper control arm. Did it not make another? Really? Oh, you know what? All this stuff, these control arms, they should have been on a different layer. This one, no. Oh, there's the new component. Okay, can rename this lower control arm. But it doesn't have the sketch. You know what, I'm just gonna delete this. Don't need that. Upper control arm 1, delete this. Delete. All right, I want to take this and I actually want to change it. I want to take this and I want to put it underneath a new component in here. So if I take this, new component, upper control arm. Okay, I want to take all of this, put it in here. Does that work? Yes, it did work. I can actually call this, rename, I can call this just control arms. There we go. So I got an upper control arm now. I just need to make a lower control arm now. So take this, rename this upper control arm. Oh. Okay, now I can take this, bodies, that, and then move copy, create copy, move it 60 mils down. Excellent. Okay, now I just need to extend this out a little bit. Maybe I'll just cut it right here and then have the new angle start from there. Okay. Wait, where's the second one? One. Ah, here it is. Components from bodies. There we go. And rename this lower control arm. There we go. Okay. Geez, that was complicated. Okay. All right. What next? So I need to get this. I need to extend it out. I need to change this angle. So what about I take this one, create a sketch. We're working on this one now. Create a sketch on this plane. Get the sketches away from me. Huh. We're going to create a rectangle. I think that's the middle. Yeah. All right. Center rectangle in the middle, and then we're gonna grow this out to like sort of like max. Actually make it kind of big. Okay. Grab this whole rectangle and we're gonna extrude it up. Finish sketch. This whole rectangle. Gonna extrude up and do a cutting operation. Cut. Okay, so that's all gone. So now we only have this front part. And now we're going to make a new sketch on this plane here. Okay, and now we want to do same thing as we did the other one from here, but now we do 80 mil. Like so. Turn this into that kind of line. And now we want to do this at 120. Oh, not 120, 60 because it's half. 60. Turn that into a construction line, and then this guy now at 120, like so. Take this guy out, delete, take this to construction line. There we go. Now take the line from this very corner here. I'm gonna just get the upper control arm away. I do want the upper control arm visible. Did I do? Do need some space. How long is this? Inspect. That is, okay, 20 mil. So I want to take a rectangle, and oh yeah, how wide is this? 8 mil. So take this, 8 by 20. 20 by 8. There. And same thing over here. 8 by 20. Whoops. 8 by 20. Like so. And then we're going to take lines, go here to there, and here to there, and then here, parallel to that. To there, and here, parallel to that, to there. There we go, that should work. Finish the sketch, grab these two, extrude downwards, 12 mil. Look at that, we're flying through this now. Minus 12. There we go. And we just need to fillet the edges. Like like so. It was 3.5, I think. There we go. So now we've got control arms. We've got upper and lower control arms. Just need to cut holes into them. But that's basically it. Hey, how's it going, David? Sorry if you were here for a while. I've been trying to concentrate. Okay, so let's see what it all looks like now. So if we go back to this, okay, and then we show the two knuckle halves, and then we show the bearings, and we show the spacer, and we show the axle hub, and I think that should be good. We should be able to flip this around, sort of like this, and there's our sort of basic attempt at a suspension. I still need a spot to put the shock though. Awesome. Well, welcome to this stream. I may put some reinforcing here because this one here we need to pass a shock through it, but the bottom one here don't really need that. So yeah, this will be nice. Short long arm suspension. Probably gonna poke a hole through these guys. And then I do need somewhere to mount the shock. I might make a hole here, then the shock will come backwards this way. But yeah, I can put a strengthening piece here. Actually, I could put a strengthening piece here, and I can actually just put a couple screw holes. But if I keep the shock over on one side, it won't be so deadly. Okay, so that's good. So let's poke some holes. Probably gonna go with a 5mm hole. Let's see if I can kind of center it in a square there. So we need to rework on this control arm, like so, on the upper control arm. And we need to make a new sketch on this plane. All right, and then, so the center here, how big is this? This is 12, so 6 in, and then 1, 2, oh, can't do that. Middle here, and then this will be 6mm. 90 degrees right there. Turn this into one of those, and then we're going to do a 5mm hole like so. We're actually going to taper the ends too. Finish the sketch, grab this guy, and punch a hole right through. Oh, cut. Like so. That's good. We can grab these guys and fillet them, make it look a little bit more circular. Whoops. Fillet. 5mm fillet. That looks just like a control arm now. Coolies. Just gonna end the pull there. The pull's not needed anymore. Okay, grab the other lower control arm, this guy here, grab the body, get a sketch right about here, same deal, grab a line right in the middle, like that, 6mm up, and then punch a hole 5mm across, punch a hole. It is pretty neat how you cut stuff. It's just basically you make the exact same form, but you just change it from a join operation to a cut operation. So you take this, and then you extrude, and then away it goes. Cut those holes. Grab this, 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 and this. Add a fillet. By the way, Fusion 360 is completely free to use for personal use. So makers, personal use, stuff like that, go ahead, go on their website, download it. You have to sign up for their, you basically get a 1-year license, but it's free. So yeah, I'm not for profit, and that's why. Hold on a second. Walmart here is telling me that they're, oh no, they're not bringing pizzas. Bastards. Okay, they're switching. So we ordered some groceries through Walmart to get a discount. Let me see. I have to tell Vero because her cans of tuna were changed from flake to chunk, or vice versa. Okay, hopefully Vero brought her phone with her, because I can just tell them to disregard. Alright, so I think I'm gonna, you know what, I was gonna strengthen this. I don't need to strengthen it. Actually, no, I'm not. I do want to strengthen it, because that's how I'm gonna attach the shock. Okay, let's see. I'm gonna go create a sketch like so. I agree, Doug. I completely agree. Actually, the only reason that we've done it this time is because they offered us a discount, so it's cheaper than just going to buy our own groceries. Basically, the discount you get is half of it is eaten up by the delivery fee, so you do end up with a bit of a discount. But yeah, I agree with you. I'm kind of picky. Like we don't get produce through that service because we're kind of picky about our produce, and I think rightfully so. Right? I don't think that's particularly odd. How much space is here? I'm gonna make a bar going across like this. Right, 5 mil. I'm just trying to figure out where I want the shock. If I go across like this, and then maybe 10 mil. $5 mil. Oops, I made a pretty shitty rectangle there. So let's say like over here. That's 5 mil across. I go up and I just go link it over here. So what if I do that? And I could put the shock here in this little basin area. So grab this, 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 and this. Then extrude that 12 mils. 12. Sort of like that. And then if I just punch a hole through here, I think it has to be an M3 I'm not sure which shocks I'm going to use, but either way. All right, so I need a new sketch over here. Can I just go see through it? Okay, draw a line from this corner over to this corner, and then this corner over to this corner. That should give me the very center. Okay, and then I will punch a 3.2 millimeter hole right through finish sketch. Punch a hole right through there. There we go. 3D printer will have a little bit of a struggle here, but that's okay. I'm actually going to close this hole up a little bit. Oops. So it's 3.2. If I remove 0.2, that should be a 3 mil across hole now. Length. Whatever. That should be right. I just want my screw to fit in there and then just not wiggle for the moment. And now I can chamfer all these, or fillet all these sides so that it starts looking pretty. And then I think we'll be almost ready to call it a day. Just have to do a little bit of wrap up, because I'll show you what the next plans are. So there we go. We're going to fillet. It's 3.5, was it? There we go. So this one's a little bit more skeletal. How's it going, Masab? Did you come over from my main channel? Or are you, did you just find me randomly on YouTube? I'd like to know. Okay, so I should be able to bring it back to here. And then I should be able to get the upper. Oh, and I just need to hide the sketches. I would like that sketch to hide too. That one? Oh, coming from main. Excellent. No, not those. That? Oh, there we go. Now it's gone. So yeah, this is our progress for today. I'm going to give these guys a color. Probably going to give them an orange, just so they stick out a little bit more. Appearance. Plastic. ABS. And then color it orangey. There and there. And I think my ball joints should be different color as well. So we already have stainless steel, so that'll be like that, the bolt, and that, the bolt. Then this guy will go blue. Done. And we're going to color. It's very hard to reach in there. Hide the knuckles. Blue and blue. There we go. Thank you. Appreciate the kind words. There we go. So that should be that. Bring back the knuckles. I think I want to color this knuckle a little bit different. Can you duplicate this? No. BS white. I don't know. 183, 255, 0. 183, 255, 0. So that's the same color. Just want it slightly different. Done. Put it over there. There we go. So not too bad progress for today, considering we redesigned the whole knuckle assembly. So yeah, these parts are all going to be 3D printed over the next couple days. So I can then take a look at what's going on. Oh, I think Vero has answered me. Give me one moment. Yeah, she says it's fine. Good. So yeah, this is what we have. Lower control arm, upper control arm. Our ball joints are all done. I'm excited to print this two-piece knuckle set with the registration marks. That's going to be pretty interesting. I'm going to run some screws through there. It's going to be probably bolts. It's just unfortunate that I couldn't sink them really and remove some of the material, but it is what it is in the end. So yeah, that should be pretty neat. I've never built something this fancy before. And so what's great though is that this should be good for all of the corners. And so really once I get the control arms and everything figured out, just multiply by 4 and also the axles and stuff. Just multiply everything by 4 and then that's it, right? There's nothing more complicated. And in fact, this part, this axle hub, this will be used if we don't have a drive axle. So if we use like a fan drive, we can just use this hub and the wheel will come over top of it. So that'll be pretty neat. So yeah, it's kind of like the effort is divided by 4, which is cool. So yeah, that's it for me. Does anybody have any Q&A questions before I take off? Anything that's on your mind, let me know. I'll answer it as good as I can, if I can. Oh, this looks so neat. Hopefully the shock fits in here. Oh, I should take a measurement too on how long that bolt needs to be. Let's go remove these knuckles. I'll remove the ball joint part of the ball. Okay, and I want to measure kind of like from here to like, okay, let's see how long this is. 33 mils. And what is it between there and there? So 12.5. So I think 20 mils will be actually plenty long. I don't even know how long mine are. No questions. Oh well. Yeah, here it is 3:43 p.m. So not quite night, but it is getting darker sooner. So yeah, I think the 20 mil length bolts will probably do. 25 to be safe. I don't think they need to be 33, but we do have a lot of space here, and plus then we can put a lock nut on it to make sure it stays locked in place. Hopefully this ball joint situation works, you know, with some grease. This stub axle will be pretty nice. So yeah, that is it. Thank you so much for joining me. Oh, I should also get the length I need for this too. Okay, let me write this down. So I need M5 by, oh, I need M5 by 25, and then I need like an M10, right, for this thing. Let's see. Whoops. From there to there, that's 44. So it's going to be at least M10 by 55. Have to be pretty long because it has to go through this and then out to the end, and then a nut will go on the top. So yeah, I'm going to check these control arms. If they're a bit ridiculous, then I'll just make something different. But yeah, that's the deal. So have a good evening, everyone. Thank you so much for joining me. And same place, same time next week. I'm going to be doing the same thing. Either I'm going to be continuing this, or I might be starting a different project, because I do need to get some stuff done. So we will see. But this was a lot of fun. I'm really enjoying this, so hopefully you guys are enjoying it too. Have a good evening, everyone.